Hello, this is Rahul. In this lecture, we will be learning path vector routings. This routing algorithms basically connects to autonomous systems or ISPs. This is the interdomain routing. What interdomain means? If more than one organization want to communicate, then this path vector routings will play important role, and this path vector routings will be used. What are the key features of path vectors routings? Actually, this path vector routing is very similar to distance vector routing. As distance vector routing, we have seen this distance vector routings were using the Bellman-Ford algorithms. Similarly, path vector routing will also use the same algorithms, but the problem with distance vector was count to infinity problems. This problem was resolved at this routing. So the path vector routings prevents the loop. Loop is what? If there is a problem of count to infinity, that is basically the problem of loop. So second key features of this path vector routing is, suppose if you want to add some policies, right? Policy means if you have a network, this is a network. Policy might be you have some problem with this router for some security reasons. So you do not want to transfer any packet which pass through this routers. So you do not want to add this router in the route of packet. So when we send packet from A to other devices, suppose if you want to send packet from A to C, you do not want to go do not want to you want to make a packet pass through this network, this router E. So in that case, you can add policies with this path vector path vector routings. So we can avoid the routers to aid in route. Suppose let's see how do we actually figure out the routes. We have same networks A, B, C, D, A, B, C, D, E. These are the routers we have. Corresponding each routers, we will prepare the routes. Let's, for examples, if you talk about A, the routes are possible from A to A. This is nothing, just A. From A to B, there is no route. From A to B, there is row, and there is a route. Sorry, I have not written. I have to write it. From A to B, there is a route, right? So let's see, from A to C, is there route? A to C, there is no direct route, so that's why I have made this as a blank one. Do we have route from A to D? A to D, yes, we have, so that's why I have written AD, right? Do we have route from A to E? Yes, we have A to E route, so that's why we have mentioned the path, right? Similarly, for the B, we will write all the routes from B to A, which is BA. From B to B, I have not written because this router is itself. From B to C, are there any routes? Yes, B to C is there, so that's why I have written B to C, and B to E is there. Yes, B to E is there, so that's why. Similarly, we will prepare the vectors for each, the vector of routes of each routers. Now, so what the process we will follow? So now these routers have their own vectors. These routers will share their vector to its neighbors. This process we call flooding. Suppose if this vector has their initial vectors, it will send to all its neighbors, and then A, B, A, E, D will update its vectors as we were doing in distance vector algorithm. Similarly, we will follow the same Bellman-Ford algorithm to update the route. Let's see how do we update the route here. Suppose we corresponding e vector e routers, we have the vectors this one, corresponding to d we have a vector this one, and this vector is sent to this one. Then the router d will update its routes. E will not update because this is sent to this one. So then D will only update its roots. Suppose if we want to say so D to A, do you have any root? Yes, D has a root. Do we have best than this DA root? By a you can actually reach the A. So this may not be efficient because DA is directly connect by E. You can actually go to D, right? This may not be always the efficient one. This is efficient one. So that is why I have not made any changes, right? What if d to b, do we have any route? D to b is not. Can you reach by E to B? We'll see in this vector. D to B, EB is a root. So you can add the root in this one. So the root is added to DEB. EB is coming from this one. So D is the first source router. So that is the reason DEB will become the path or root. D to C, do we have any path in D? We don't have. So we will use this vector E. So can we reach from D to C via E? Yes, we can reach. So D to E to C, we have a route. Send D to C we don't have. We will use this one to find out the route. So that's why DEA, you can see in pictures DEC. So that is the reason I have written DEC. Similarly, you can compute all the roots and you can write over there. What the updations rules are? If you are asked to write in the form of vectors, you can write update D is equal to best. Best will find out both of one of these two distances, either D vectors or comma D plus. This plus means concatenation. This is not plus one, right? This is not arithmetic sum. This is concatenation of root, right? We will consider the policy as well. Suppose if any vector is not being added, do not want to add, simply you can avoid the root. Suppose if you do not want to add this vector, this router, this router in the path, you do not make any change once you get vector from router E. That is the reason. So if you do not get any change, you do not make any change on D once you get vector of E, that means you are avoiding the vector routers E, right? You are avoiding the router E. Same process we will follow for other routers to find out the routes to other one, right? So the protocols we use, the protocols which use the routing path vector routing, the protocol is BGP. As we know, the protocol is more than the routing algorithm. So that's why what are the key steps of BGP? First step is peering. Peering means routers will simply send a request message to its neighbors to establish a connections between the routers. So in second step, what we do, information exchange will happens where the any routers will send its forwarding table to the its neighbors, right? The best out of when any routers gets information from or vector from its neighbors, then the router will update its vectors or best routes by using distance vector algorithm with consideration of policy, as we have done just a moment before. So we continue the process until there is a change happens in any forwarding tables or vector corresponding to any routers. If it is happening, then we will continue the process, otherwise we will stop. We can say in other word, if until the stability of the forwarding tables, we continue this process, right? So what are the disadvantages of BGP is a complex. First one is a complexity. Second one is a slow conversions, right? What are the advantages of BGP is the first main and biggest advantage is escapabilities, right? Why it escapability is a main advantage of this BGP is you once you will add any routers in the networks, then only need to send the routing vectors to the device, then other routers will update itself the route. So the scalability is very easy, policy based. This is also good things with this BGP. And one more thing is loop preventions. Loop preventions means count infinity problems was resolved with this BGP protocols. And the third one is global connectivity. So global internet for global internet connectivity, we use the BGP protocols. Thank you.